Let's give circumference a whirl. The following notes are over circumference of circles. Please feel free to pause your video at any time. We will be copying down a lot of notes onto the recording sheet that you got from your teacher. Please feel free to pause as often and for as long as you would like. All the words that need to be filled in on your recording sheet are circled with a red mark. So to review, a radius is a line segment with one endpoint at the center of the circle and the other endpoint on the circle. A circle has infinitely many radii and are all the same length. Radii is just the plural version of radius. A diameter is a line segment that passes through the center of the circle and whose endpoints lie on the circle and has infinitely many diameters, and all of them are the same length. So here you can see that your diameter goes from a point on the circle to another point on the circle through the center. A radius starts at the center and goes to any point on the circle. You also can tell that this blue line, if we were to bring it down, would be the same length as half of this red one. In the same circle, any two radii are equal in length to any one diameter, which is where we get the formula 2r is equal to d, and the circumference is the distance around a circle. When we're looking at circumference and diameter, since the circumference of a circle is dependent upon the length of its diameter, a table of values can be used to represent the relationship. So here in our table we have the diameter, which we can refer to as x, and the circumference, which we can refer to as y, because first we have to have a diameter, and then second we have a circumference. So x is independent, y is dependent. If we take C divided by D for each row of the table, we will notice that we get 3.14285713. How would you describe the relationship between the circumference and the diameter of circles? The answers are the same for each row, and when that happens, we call this a proportional relationship. What is the constant of proportionality, or the K? It's 3.1485713, which is also known as pi. All circles are proportional to each other because no matter what the diameter, you always take your diameter times your radius, times your pi, which is 3.14, and that will give you your circumference. K, or pi in this situation, is your constant of proportionality. The value of C over D is the constant of proportionality that's used to find the circumference of any circle. The value of C over D is also known as pi, or the pi symbol, which is a Greek letter of the alphabet. Pi is an irrational number that is approximately 3.142857143. Oh, I think I left a number out on my other slide, which is often rounded to 3.14. Pi is considered irrational because the number does not end or have a repeating pattern to it. 22 over 7 is an exact form of pi. If you take 22 over 7 with a calculator and divide it, you'll get 3.142857143. Because the value of C over D is the same for any circle, what equation can be used to find the circumference? We use the circumference is equal to pi times diameter. Use the equation with a value of pi for 3.14. When you take the diameter times 3.14, what do you notice about the circumference you get? That's right, it's not exactly 5.5. If you take 3.5 times 3.14, why do you not get exactly 11? We do not get exactly 11 or any of the circumferences on the table because we must keep in mind that 3.14 is a rounded value for pi. We still have our same circumference formula, taking pi times the diameter. If we decide to use 22/7 for pi to verify the values, you could take in your calculator 1.75 times, put in parentheses 22, divided by 7, and close your parentheses. And what do you notice about each of the answers you get for circumference based on the diameter? We get the exact answers. We get the exact answers when we use 22/7 because 22/7 is the exact value for pi. Since any two radii are equal in length to one diameter in the same circle, we can say that 2 radii, 2 times the radius, is equal to the diameter. So we can also use this information to create a second circumference formula. The diameter can be replaced with 2 times the radius. Pi is still pi. Your diameter still has the same value as if you took 2 times r. Now, if you're in my class, you will have a green handout that has 2 circles on it. Please refer to that handout now to fill in the following information. The circumference of a circle is a little more than 3 diameters. The circumference of a circle is also a little more than 6 radii. The number of radii needed for the circumference of a circle is twice the number of diameters needed for the circumference of the circle because 2 radii equal 1 diameter. So if we look at this in picture form, here's our circle. This section of the circle is the length of the diameter. This second section of the circle is the length of your diameter. And this third section is also the length of your diameter of a circle. And then we have a little bit more. Remember, pi was 3.14, which is 3 and a little bit more. As we look at the circumference example, starting here, going to here would be a diameter. Within this diameter, we have 2 radii. Within this second diameter, we have 2 more radii. In our third diameter, we still have 2 more radii. That is a total of 6 radii and just a little bit more. Or remember, 2 times 3.14. When finding the circumference of a circle with either c is equal to pi d or c is equal to 2 pi r, it's not necessary to use 3.14, 22/7 for pi. Sometimes we can just use 3 for pi when an estimate is appropriate. There are also times we can leave our answers in terms of pi when it's appropriate. For example, we can write 5 pi for the answer rather than multiplying 5 times 3.14 and getting 15.7. The nice thing is if we leave our answer in terms of pi, we don't have to worry about multiplying and moving our decimals. So now you have Giving Circumference a Whirl practice sheet. Please go ahead and practice that and come to class with any questions.